So, good afternoon, everyone. So, I am a student of Srinivas Ramanujan Institute of Technology, Ananda. So, today my topic is about structural design principles on the subject software engineering. And my name is Manju, and my roll number is 592. So, let us go through on the topic Introduction to Structured Design. So, the basic definition of structural design is about structural design is a methodology that transports the output of structured analysis. For example, data flow diagrams or DFD diagrams, etc. So these are the basic examples of structured design. So here the main purpose is to create a hierarchical modular representation of software architecture for easy implementation. So here the focused areas are defines modules making up the system, specifies module dependencies, details parameters passed between modules. So here is the context, acts as a bridge between analysis. Visual is include a small data flow diagrams, etc. So here is the notes, emphasize that this is about architecture and laws. So structured chart overview. So here is the title, structured chart, the blueprint of software. The basic definition of structured chart is a graphical representation of this software architecture, shows modules, invocation, relationships, and data flow. The main key concepts are, here is six concepts respectively: modules, invocation arrays, data flow arrays, library modules, selection and reputation. So here are the characteristics: hierarchical structure with a single root module, no cyclic dependencies between modules. So the structure may be like this. So hierarchical structure with a single root module, no cycle dependencies between modules. So the basic building blocks are rectangular boxes, module invocation arrows, and data flow arrows. So here rectangular boxes represent modules. For example, functions, procedures, or subroutines. Annotated with the module name, and second one is module invocation arrows. So indicate control flow from one module to another. Direction of the arrow shows which module invokes first. Data flow arrows. Third one is data flow arrows. And here small arrows alongside invocation arrows. Annotated with the data name being passed. So library modules represented by double-ended rectangles contain frequently used modules. For example, utility functions. So second one is selection, conditional invocation, represented by a diamond symbol, and it indicates that one of several modules is invoked based on the condition. Because it is selection invocation. So third one is repetition. Repetition is nothing but looping. Like in a programming, we use for loop or while, do while, etc. So represented by a loop around the control flow errors. So indicates that modules are invoked repeatedly. Let us go through module invocation and data flow. So module invocation arrows shows control flow between modules. Here is the some do not specify functions that are frequency of invocation and order of invocation. Data flow arrows. So shows data movement between modules annotated with the data name. For example, input or output or parameters, etc. Here is the example. Module A invokes module B and passes data X. Here is the basic diagram of the module invocation and data flow. So let us consider two modules, that is module A, that is invoked by module B, and the data flow is taken as X. So let us go through library modules. Library modules are nothing but reusability in design. Here is the definition. Modules that are frequently called by other modules represented by double-ended rectangles in structured charts. And in library modules, the main purpose is to promote code reuse and reduce redundancy. Redundancy means reduction of errors or duplicates. So simplify maintenance and updates. So here is the example. A math library module uses by multiple modules for calculations. Let us show by a diagram. Let X be the module 1 and Y be the module 2. So math library is the constant module. So that is invoked by modules X and Y respectively. So selection and repetition. Uh, in Selection means conditional invocation represented by a diamond symbol indicates that one of several modules is invoked based on a condition. So for example, module A, condition and module B. Here is a modules. Uh, Here there is a condition between module A and module B, and final output is the modules. So repetition. Repetition is nothing but looping represented by a loop around the control flow errors and indicates that modules are invoked repeatedly. So here is the example diagram. Module A, looping statement and module B. So layered design principles. Some key principles are single root module, no cycle dependencies, abstraction. So in single root module, one top level module in the structured chart, no cycle dependencies. Modules should not invoke each other cyclically. So in abstraction, lower level modules should not be aware of higher level modules. So proper layered design. Modules are arranged, organized in layers or levels. Higher level modules invoke lower level modules. Poorly layered design. Here is two types that are proper layered designs and poorly layered designs. In poorly layered designs, cyclic dependencies are lack of hierarchy. So example diagrams for proper and poorly layered diagrams are so let us go through advantages of structured design. Modularity, reusability, maintainability, clarity, and scalability. Here is the major advantages and let us explain one by one. So modularity breaks down the system into manageable modules. Reusability means the code will be reusable wherever we want to use that. So promotes reuse of library modules. Maintainability simplifies debugging and updates. Clarity provides a clear visual representation of the system. Scalability facilitates the addition of new modules. So finally, in the conclusion, structural design transforms DFD into structured charts, focuses on module structure dependencies and data flow, promotes modularity, reusability, and maintainability. So the final output of the structural design principles are here is we can promote modularity, reusability, and maintainability. Here is the major advantages of the structural design principles. So thank you.